My left-hand column contains examples of entire radicals. My right-hand column contains examples of mixed radicals. What do you think constitutes an entire radical as opposed to a mixed radical? Well, you might notice mixed radicals have a number in front of the radical sign. So a mixed radical is a product of a number times a root. An entire radical is also a product of a number times a root, but in each of these cases, the number that we're multiplying out front is a 1. So it appears as though everything is under that root sign. An entire radical is 1 times a radical. A mixed radical is any other number than 1 times a radical. If we go to simplify a radical, there are 3 things that constitute a simplified radical. So a radicand cannot have any perfect square in it for a square root. If we have a cubed root, there cannot be a perfect cube in there. So no removable factor depending on what that index is. The radicand cannot contain any fractions or decimals unless the original question begins with a fraction or decimal there. And we cannot have any radicals in the denominator. We know that the square root of 36 is 6 and the square root of 100 is 10. Both of these are perfect squares, but we're going to use them to illustrate a point here. What is a number that divides evenly into 36? If we go with the number 9, 36 divided by 9 leaves us with 4. So I'm going to break this up into the square root of 9 times 4, multiply those together, we'll get back to our 36. And then I'm going to take the square root of each of those numbers individually. We know that the square root of 9, that is a perfect square. There is no more radicand left. I'm just going to pull that 9 out and get 3. And the same thing with that 4. I'm going to square root 4, which is a perfect square. There's no more radical left, and I'm going to get 2. 3 times 2 is 6, which we know is the value of the square root of 36. Okay, let's try this again. So we have the square root of 100. What's a number that you know divides evenly into 100? And there are a few different options, but let's say you go with 25. 100 divided by 25 is equal to 4. So again, I'm going to write 100 as the product of 25 times 4, and then I'm going to split them up and just say the square root of 25 times the square root of 4. The square root of 25 is a perfect square. The square root of 4 is a perfect square. The square root of 25 is 5. The square root of 4 is 2. I can multiply those two together and get a value of 10, which is what we know the square root of 100 is equal to. So we can take any radicand and break it into its factors. The root of the product of those factors is the same value as if we square root each of those numbers individually and then multiply them together. All right, so we're going to simplify each of these radicals by writing them as equivalent mixed radicals. This is already a mixed radical, but there is a perfect square in there, so we're going to remove that. The first thing you want to do, especially if you have a whole page of these, is to begin by making a list of your perfect squares across the top of your paper. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, etc. And then what you can do is take a look at the radicands. So we have 18. What is the largest perfect square that will divide evenly into 18? So if you go along your number line, you can see 18 is going to be in here. 16 will not divide evenly into 18. 9 will. So we can go ahead and break this up. The square root of 18 is equal to the square root of 9, and then 18 divided by 9 is 2. So we can split that up. 9 is a perfect square. So if we take the square root of 9, we're left with 3. We're going to put the 3 on top, and then what we're going to do is multiply everything up top by everything out front. So in this case, we have a 1 out here. So 3 times 1 is 3, and then we still have that square root of 2 in the radicand. That's an irrational number, so that is going to stay there. Our next one, we have a radicand of 75. 75 is between 64 and 81, so we're looking for the largest number that will divide evenly into 75. So 64 will not divide evenly, nor will 49, nor will 36, 25 will. So we can split this up into the square root of 25, and then 75 divided by 25 is 3. So I'm going to take the square root of 25, that's a perfect square, and we can put that on top. The value is going to be 5, and then the square root of 3 is irrational, so we're going to be left with 5 times the square root of 3. So in our next one, we have a square root, and I can see that there is a perfect square that we can divide out of 32. It's going to be 16. So we're going to split this up into the square root of 16, and then 32 divided by 16 is 2. The square root of 16 is 4, so we're going to take the square root, pull it out of there, and we're going to put it up top, and then the square root of 2, that's irrational, that stays as a radical. So now we have 4 times 2 leaves a coefficient of 8, and we still have the square root of 2 in the radicand. And then if you wanted to check if these were in fact equivalent, we could enter 2 times the square root of 32. So it's going to give us, because that's irrational, it will give us an irrational decimal number. And then we're going to go 8 times again the square root of 2. And if those two decimals are the same, we know these are equivalent. However, you have to be careful. If there's any removable factor within that radicand, it's equivalent, but it may not necessarily be simplified. So don't just check the decimal. Make sure that you simplify first. Make sure you don't have any perfect squares left in a square root, and then you are simplified. This next one here, I know the largest perfect square that divides evenly into 98 is 49. That leaves us with the square root of 2. The square root of 49 is 7, so we're going to pull out a 7, multiply that by 3, so we end up with 21 times the square root of 2. And then in this last one, I know that 25 is a perfect square, so I'm going to take the square root of 25. There's no more radical left. I'm going to pull out that 5. We're going to multiply that 5 by the 2 out front, and that gives us a value of 10. The next radical that we're going to simplify happens to be a cube root. So now I've made a list of my perfect cubes. We have 1 cubed, 2 cubed, 3 cubed, 4 cubed, etc. 54 is the radicand, so it's going to be between those two numbers, and you're going to check, does 27 divide evenly into 54? And it does. So we can split this up into now the cubed root of 27 times the cubed root, and if we go 54 divided by 27, we're going to get a value of 2. So now when I take the cubed root of 27, that is a perfect cube, we're going to put the 3 on top, and then we're going to multiply that by 3 times the cubed root of 2. So our simplified value will be 3 times the cubed root of 2. And again, you have to make sure you put the index there. The cubed root of 2 is a different value than the square root of 2. We now have a fourth root, so we can begin making a list. 1 to the power of 4, 2 to the power of 4, 3 to the power of 4, and we don't have to go very far because the numbers get high awfully fast. So I can see that 16 will divide evenly into 80, and then 80 divided by 16 is 5. So when we take the fourth root of 16, that's going to give us a 2, so we can put that up top, and then we're going to multiply 2 times 1 is 2, and we still have that fourth root of 5 left. So again, remember that index there. 2 times the fourth root of 5 is equal to the fourth root of 80. If you have to simplify a really large radicand, you don't necessarily have to pull out the largest perfect square. You just want to make sure that in the end, there is no more perfect square left in the radicand. So find any number that's a perfect square that will divide evenly into this radicand. So if I divide by 4, then we can take the square root of 4, which is 2, so put that on top, and then keep going. So is there another perfect square that will divide evenly into this value? And again, we can divide by 4. It's not the biggest number, but you can just pull out any number. So take the square root of 4, put the 2 up top. Is there a perfect square that will divide evenly into 405? We can divide by 9. The square root of 9 is 3. Put that 3 on top. Check. Is there a perfect square we can still take out of 45? And again, we can divide that into 9 times 5. The square root of 9 is 3. And now there is no more perfect square other than 1, which won't actually change the value when we divide by 1. So this is left in the radicand. And then we can go 2 times 2 is 4, 3 times 3 is 9, 4 times 9 is 36 for the coefficient. Now can we reverse the process? So if you were given a mixed radical, could you turn that back into an entire radical? Well, in order to pull out this 3, we ended up square rooting the 9. So in order to get this back underneath, we're going to square it, which is the opposite of square rooting, and then we're going to multiply it by what's there. We square rooted the 5 to pull it out. We're going to square the 5 to put it back in. 5 squared is 25. We're going to multiply it by the 11 that's already in there. 25 times 11 gives us a value of 275. And again, you can check this on your calculator. So this should have the same value as this, and make sure that you cover the entire radicand with that radical sign. Again, square rooted the 4 to take it out. We're going to square the 4 to put it back in. 4 squared is 16. 16 times 3 gives us the square root of 48. Now, we don't have to write this out every time. I just did that so you can see what we're doing. I would just take a look at this and say, okay, we're going to put this back in. 2 squared is 4. 4 times 7 is 28. Boom, you've got the answer. Now, this is a cube root. We cube rooted the 2 to pull it out, so when we put it back, we're going to cube it. So we now have 2 cubed, which is 8, times 5, which is 40, and don't forget, because this is a cubed root, you have to make sure that you have the 3 in that index. And our final question, again, is a cubed root, so when we put this 1.5 back in, we're going to cube it. Now, this is a decimal given to us in the original question, so when we multiply that by 6, we do end up with a decimal value, but because there was a decimal in the original question, we're going to leave it like that. This is not simplified, but it is an entire radical. And in our last question, we're given 4 irrational numbers and we're asked to place them in ascending order. So ascending, we're going from smallest to largest, and we cannot use a calculator. So the easiest way to do this is to turn them into entire radicals, and we can see that the square root of 32 is already an entire radical. So let's go ahead and convert those into entire radicals, and then we can compare the radicands. So if I put this back in, I'm going to have 2 squared is 4, 4 times 18 is 72, 2 squared is 4 times 3 is 12. 3 squared is 9 times 2 is 18, and we already have the square root of 32. So now ascending, we're going smallest to biggest. So I can see 12 is the smallest, so that one's going to go first, and then 18 is my second smallest, and then 32, and my largest radicand is the square root of 72. However, when you go to give the final answer, you need to make sure that we use the values given to us in the original question. So my smallest value, the square root of 12, that is 2 times the square root of 3. My second one, 3 times the square root of 2, etc. So just make sure anytime you're ordering, we can do this to help us organize our information, but then always final answer, give the values as they were given to you.